Imagine, just for a second, living in a country that is almost completely swallowed by sand. We're talking a place where more than 95% of the land is just straight-up desert. So how do you keep a nation of over 37 million people not just alive, but actually thriving and expanding their industries? Well, it requires some of the most mind-boggling large-scale engineering on the face of the planet. Welcome to this explainer, where we're going to unpack the incredible source material behind Saudi Arabia's absolute masterclass in water security.
Now, to truly appreciate what they've built here, we really have to wrap our heads around the sheer hostility of this environment. Saudi Arabia gets an average annual rainfall of less than 100 millimeters. Less than 100. There are literally zero permanent natural rivers in the entire country. And summer temperatures, well, they regularly soar way over 45 degrees Celsius. It's a harsh environment where nature simply does not provide enough water for basic survival, let alone for, modern agriculture or these massive, sprawling urban centers.
Okay, let's dive into this. Because the answer to this question represents a generational undertaking. To supply a population that's densely packed along the coasts, but also spread way out across the arid interior, Saudi Arabia has had to look away from the sky and entirely toward the sea. Historically, the agricultural sector heavily depleted the non-renewable fossil aquifers sitting beneath the sand. But today, under their national water strategy, that groundwater is strictly treated as a strategic reserve. Now, a massive 60% of the kingdom's potable water demand is met purely by desalination, while groundwater makes up 30% and surface water is just a tiny 10%. The sea is quite literally their absolute lifeline.
Section 1. The Desalination Magic.
So how exactly do they turn a harsh, super salty ocean into a refreshing glass of drinking water? Let's trace the journey of a single drop of seawater, starting right at those massive desalination complexes situated on the Red Sea and the Persian Gulf. Our drop of water makes three main stops. First, billions of liters of seawater are sucked into the intake facilities. Second, it gets pushed through an intense filtration process called reverse osmosis. And finally, it goes through remineralization, where it's conditioned so it's actually safe and pleasant for us to drink.
To really grasp the scale of Step 1, just look at the Ras Al-Khair power and desalination plant over on the Persian Gulf. This thing is a mammoth hybrid facility. It processes a staggering 1.036 million cubic meters of water every single day. To put that into perspective for you, that's enough water to fill over 400 Olympic swimming pools every 24 hours. That water goes on to supply the capital, Riyadh, as well as a nearby aluminum oxide refinery. The sheer volume of water being pulled from the sea and processed here is it's hard to even wrap your head around.
So the really crucial part is how they actually remove the salt, which makes up about 3.5% of seawater. And this is notoriously difficult to do because salt ions cling so tightly to water molecules through a natural electrostatic attraction. Reverse osmosis essentially breaks that bond. It applies a pressure that's greater than the natural osmotic pressure, literally forcing the water through an ultra-fine membrane while leaving all the salt and impurities behind.
And let me tell you, this requires some extreme physics. To push the water through those tiny membranes, high-powered centrifugal pumps have to generate an immense 60 bar of pressure. Think about that. That is roughly 60 times normal atmospheric pressure. It is a violent, highly energetic physical process just to separate salt from water at the molecular level. And this brilliantly illustrates the final step at these coastal plants. Because reverse osmosis is so incredibly effective, it strips out almost everything, which actually leaves the water tasting essentially flat. So during remineralization, they carefully re-add small amounts of essential minerals, things like calcium and magnesium. This adjusts the pH, bumps up the alkalinity, and brings back that natural taste, making it healthy and totally ready for your tap.
Section 2. The Invisible Steel River. Now, creating all this fresh water on the coast is really only half the battle. Now you actually have to move millions of cubic meters of it hundreds of kilometers inland across scorching deserts to reach major population hubs like Riyadh. Since Saudi Arabia lacks natural rivers, well, they just engineered their own. They've built this invisible, underground river of steel. It's a nationwide water pipeline system that essentially functions as the entire country's circulatory system. The infrastructure required to pull this off is staggering.
We are talking high-strength carbon steel pipes, literally the exact same heavy-duty engineering you'd see in the oil and gas industry. Some of these pipes have diameters of 72 inches. That is nearly 2 meters wide. You could almost stand up inside them. Building this network costs an average of $3 million per kilometer, and that doesn't even factor in the massive booster pumping stations they need to literally push all that water uphill across the desert terrain.
Let's actually look at a specific example here. To get water from that massive Ras Al-Khair plant we talked about earlier, all the way to the capital city of Riyadh, they built a 72-inch twin steel pipeline that runs for 267.5 kilometers. That specific pipeline alone is carrying 900,000 cubic meters of fresh water directly into the heart of Riyadh every single day.
Section 3. Building the $16 billion grid. As the population and industry keep growing, the demand for water is expanding at about 3 to 4% annually. And the government? They are not stopping with their current infrastructure. Guided by their Vision 2030, they are aggressively expanding this invisible grid. I mean, the current national network is already massive, sitting at around 8,400 kilometers, but the planned expansion is going to add another 3,500 kilometers of brand new transmission lines. This massive upgrade is going to distribute an additional 4 million cubic meters of desalinated water per day, deeply enhancing the kingdom's long-term water security. This pipeline expansion alone represents an estimated $16 billion investment. That's roughly 60 billion riyals, and a really significant chunk of this is being funded through strategic public-private partnerships, or PPPs. Basically, the government is bringing in private developers and big investors through these long-term concession agreements to build, own, and operate these massive transmission lines.
Let's move to and see how this builds into an interconnected national web, looking at just a few of their upcoming megaprojects. You've got the Riyadh-Qasim water transmission pipeline stretching 859 kilometers, the Jubail Buraida pipeline at 587 kilometers, and the Rias Rabigh line right on the west coast. They are literally knitting together coastal plants to inland demand centers, creating this incredibly connected, fully redundant grid for water conveyance.
Section 4. A sustainable desert future. Now, all of this massive infrastructure brings up a pretty critical question. How exactly do you decarbonize a process that is this energy intensive? How does a system like this survive in a world that is rapidly trying to go green? Well, the answer lies in technological evolution. The kingdom's water strategy has come a long way since 1907, back when they relied on a single condensate machine sitting aboard a ship in Jeddah. For decades after that, they relied on thermal multi-stage flash distillation, which was literally just boiling seawater, requiring massive amounts of fossil fuels. But today, they have shifted almost entirely to the much more energy-efficient reverse osmosis. And looking ahead to the future, they are integrating renewable energy directly into the water grid itself. A prime example of this shift is the Jubail 3A independent water plant. It is the very first facility in Saudi Arabia to integrate solar photovoltaic power generation directly on site. By adding 45.4 megawatts of solar power, they are covering about 20% of the entire plant's energy consumption. That cuts their grid reliance and reduces carbon emissions by 60,000 tons annually. They are literally using the scorching desert sun to power the extraction of fresh water from the sea. It's brilliant. Which leaves us with this final thought. You know, we so often just take turning on the tap for granted. But in Saudi Arabia, producing a single cubic meter of water from the sea and pumping it all the way inland can cost around $5, compared to just a few tens of cents in places that are blessed with natural freshwater. When you stop and consider the billions of dollars, the 60 bars of physical pressure, and the thousands of kilometers of buried steel required just to bring a single glass of water to a dinner table in Riyadh, doesn't it completely redefine how we value every single drop?